So thank you, Dorit, and thank you all for joining us. Actually, this specific panel is about quantum and investment, a bit about technology. We will really try to focus on really what interests you. And as you can see, and you probably all reading the papers, it seems like there is a lot of money around quantum technology, and it seems like many investments there. I'm from the Israel Innovation Authority, and we have invested more than 300 million shekels in the last 5 years in quantum technology. And I have to say that the first time we have decided to invest in quantum technology was we were approached by the Ministry of Defense, and they say, this is an enabling technology, you have to put money. But we really look at market potential. So my first question actually to all of you is, what made you invest for the first time in quantum technology?
Hi everyone, great to be here. I'm Dorin, I'm heading NightDragon in Israel and Europe. So NightDragon is a US-based fund, and we're focused on growth. We're focused on building big companies. And so the first thing that is really important to us is to make sure that we're investing in a big market, a big enough market to grow multiple companies into multiple billions of dollars. So when you look at quantum, the market size is gigantic. If you compare it to cyber, you have some of these really sought after markets that are 5 billion, 10 billion, 15, 20. But when we talk about quantum, we're talking about a $200 billion market size in the next few years. Beyond that, we are talking about value generated in the value of 1 to 2 trillion. So there's a lot of room for multiple players to grow big. Another part of our strategy is that we help companies go public. Dave DeWalt is our founder, and he himself has taken multiple companies public. He was founder of CEO of McAfee and others. So we look at that as a clear exit path. And when you look at the quantum exits that have happened in the last few years, there's a substantial amount that have gone public. IonQ, Rigetti, D-Wave, et cetera, are valued at just those 3 or 4 combined are about 40 billion plus in market cap. And you compare that to the few companies that did M&As that are valued at just about 1 or 2. So the path of IPO being very clear, very reliable for quantum is also a factor. And then I'll say one last thing is that the government funding and the government grants and standards that play into adoption significantly reduces the risk, because not every area of quantum is investable right now. It's not a revenue game, it's a potential game. And so you have to be confident that certain things are going to drive revenue no matter what. And so that's definitely there in the quantum space. So to sum up, I think it's an area that people don't yet understand just how big it's going to be. And it's very interesting for us.
Well, Dorit, you left. Oh, you want Nir first. Okay. So Nir actually is the CEO of Classiq, and I think that's the biggest company, quantum computing, I think, in Israel, at least in terms of fundraising. So Nir, tell us what made you go into this area.
Okay, so basically, I think the first thing to ask about quantum computing is why the hell we need another type of computer, right? We have 70 years of classical computers, and basically all of them have the same DNA, right? Your iPhone, your laptop, and the most powerful supercomputers in the world, they all operate similarly. So why we need a totally different type of computer? And moreover, how come that the motivation for these computers is with us for the past 45 years and is still valid? What's the connection between the computers we had in the 80s and today? So the motivation is very simple. There are problems that are world-changing that even if you build a computer at the size of the sun and let it work for 10 billion years, it can solve. Just can't solve. It's too complex. And quantum computers excel at these type of problems. And fortunately or unfortunately, you decide these are world-changing problems, right? I can give like many examples if you like after, but so we knew, 5 years ago that the world is going to change, something that is happening once in 70 or more years is going to happen, and someone will build this computer, yet there is no software, right? So someone should build the software, the operating system, the compiler, the development environment, and potentially, if they do really well, they could become the Microsoft of a new era in computing. So that was kind of the motivation. And of course, there is a long way to go. But I think, as Dorin said, this is part of the beautiful aspect of this industry, that it's an industry, it's a computing revolution, and this is not something that is happening every day.
Yeah, so Dorit, you left Checkpoint, one of the Israeli biggest unicorns, and you have decided to go to a new area in Qbeat. And please tell us why you also want to change the world.
Sure, I always wanted to change the world. That's how I ended up being in cyber in the first place. I'm a computer scientist by nature. I did the PhD in algorithms and complexity, and I associate myself with computation technology. And whatever Dorin and Nir said is very accurate. This is a technology that is bounded to change the world in the sense that it will solve problems that we don't know how to solve. Otherwise, it won't be just an acceleration. But then the second question is, when you come to invest in something or dedicate your energy to it, is how close we are. Is it just like an imaginary future, or is it something real? So I would set here some stage about why is it coming. It's coming because there are quantum computers in the world today. They are being used. There are about 150 enterprises that uses them. And they use them to solve problems. BMW, Airbus, HSBC, JP Morgan Chase, they have quantum groups and they try to solve problems. The problem is that the computer is too small. So the problems they solve are kind of smaller instances of problems that could be solved in a different way. In what sense is the computer too small? It's too small because it could be simulated by a classical computer still. But in not very long future, the computer will be big enough so that this simulation will no longer be automatic. And whatever we will solve in quantum would be starting to be unique, and that's, in our opinion, the start of inflection point. To add to this, you could see many other indications, conferences, plans in the academia, academical people that live into funding companies, progress in computing advantage meters that are being published, and publications around the world about groundbreaking results in these spaces. So in short, it's a huge space with great potential, but it's also coming.
Yes, it's coming, and actually the acceptance, the market acceptance actually is still in vague somehow. We start to see more and more problems which are solved by quantum computers, but we are still not sure if we are there. So it all depends on which professor do you ask. And complexity, as you said, Dorit, is part of the game. And this is, I would say, one of the parameters that's well described the innovation process of the quantum technology. So my question to you is actually, what's differ the quantum technology from the part of the innovation process from other technology? Why is it so different? Why do we somehow not able to solve exactly what to develop and what are the new challenges?
Okay, so this is something that works completely differently. You have to, in order to leverage the force of quantum, you have to make your computation work while the whole system is in undetermined state, meaning in superposition. So you take many elements that are in superposition and you apply computation to them. That means that the computation have very different parameters, gates like and or would not work. Regular computation would not work. Every term in quantum that we have on the table, memory, networking, error correction, any word we would choose is a completely different meaning in the quantum space because it's a computer that operates on some physics elements and obey the physics rules, which is very different than a classical computer. This means also that when we say the potential for have exponential problem resolved, it's not that we take every problem, throw it on the computer, and it solves it by magic. We have to have the right algorithm in place in order to solve it. That's the whole kind of big step ahead, but that's the whole excitement as well. It's really the invention of something new.
Dorin, from an investor point of view, how would you look at the innovation process of quantum computer? When is it the right time, I would say, to invest in a quantum computing company?
6 months ago.
By the way, we're all investors in Classiq, so very proud of Nir here. Me too. Yeah, all of us, yeah. So I'll zoom out for a second and I'll say, okay, quantum is a very hardware-intensive business. You have to be comfortable as an investor with a lot of expenses and maybe lower efficiency for a long time. We have not made a play in hardware for that exact reason. Right now, there is an arms race. There's all these companies that are valued at very high valuations, multiple billions, right? And they're still trying to solve a lot of hardware milestones that need to get there before we even reach quantum advantage. Quantum advantage meaning when a quantum computer outperforms a classical computer. And that gets us one step closer to commercialization. So we're still rather far from that. So when I'm building our NightDragon's quantum investment strategy, I'm looking for other layers of the quantum process. Not yet hardware, because we just don't feel like it's low enough risk for us. But that's why we look at, the software layer or the future Windows, the future Microsoft of quantum. We look at the control layer. We look at other layers that put everything together and kind of make quantum more practical so that we get one step closer to the everyday person being able to use a quantum computer. And when you look at like different tech transformations that happened in the past, it all started with government funding, even the internet and AI. Decades and decades ago, the government started funding these projects. And initially it was more academic, it was more scientific. Only those kinds of people were really tapping into it. And in quantum, it's been like that up until it's still heavily like that. But right now we're just starting to go through that transformation where we're accelerating the path to commercialization. Does that answer the question?
Yes.
Okay, good.
Yes, it does. So Nir, what would you say? When is the, okay, you said 6 months ago, but actually, if you look at the different layers, as Dorin said, it's easier to invest in the algorithm layer maybe because then you are technology agnostics, but in some cases you still have to choose the right processor. So I know it's not really your domain, but if you look at the hardware level, is it a good time to invest? Does the innovation process is a bit different there, or you think that we are mature enough to go for a specific technology?
I think it's a good time to invest in a portfolio of 5 hardware companies. It's too early to invest in one because we still see, what's the problem with building a quantum computer, right? In the quantum nature is known, right? We know how it works, but in quantum, so this battle could now disappear and reappear in, Haifa. It won't happen here because it's a macroscopic object. So it could happen, but it's very unlikely, right? So the problem of building a quantum computer is building something macroscopic. You can see it, but it should work in a quantum way. So that's a big hardware challenge. Now, there are several very different ways to build these machines. Photonics, iron trap, superconductor, Qbeat, diamonds, neutral atoms, and so on and so on. The progress on all fronts is amazing, right? And if you need to bet on the first company to reach quantum advantage, I think it's likely to be either Google, Honeywell, IBM, maybe Microsoft, maybe Harvard University. But then if you need to bet on who will be the first to bring the full-scale quantum computer, I can give you my best answer, which is completely not useful because you will have like at least 10 companies. So from our perspective and also from the end user perspective, it's better to bet on the race rather than the winners. When you build the software, you should build it in an agnostic way, a cross-compiler, a upper layer OS, and so on. But the race is still on.
Okay, so first, with quantum, maybe the food will reach your mouth statistically, so you could hope for that to happen. If not, I have to be quick. I'll say that I don't think that in the near future one winner takes it all. For the different quantum computers called modalities, there is a race, as Nir said, and each modality has its pluses and minuses, error correction, time of computation, and other elements. So in the foreseeable future, there would be multiple winners and optimized hardware usage for applications. And maybe many years from now, we will realize like prevailing technologies and consolidation, and it will shrink. But for today, if you want to be in quantum, you have to consider the whole stack, not just the software, from the hardware upwards. It's part of understanding the space. There is not just the core computer in the hardware, there are other elements, the memory, the controllers, and other elements, they all play together. And I totally agree with Nir that if you are to invest, you should have a portfolio.
So surprisingly, we're a small country and we have a player in each one of those areas you have mentioned. That's really amazing, I think. But just, we have only the last minute, so if you have maybe just small remarks about what's the next big thing in quantum technology. Where are we going? Where are we heading? Nir and I was talking about the fact that the first sector maybe we have to look at it is the health sector. So it might be pharma, it might be the imaging, but what's the next big thing in quantum technology?
Like the sector.
It might be the sector, it can be also hardware.
Okay, I think the first value we'll see when we do reach that quantum advantage and get practical use cases is in the drug discovery sector. And I think not enough people understand that, it means that we're going to be able to create new drugs because quantum mechanics comes into play, and things that classical computers can only do on approximation, a quantum computer can do 100% all the way. And so that creates brand new drugs, brand new materials, things that are going to impact our world in different ways than we know. So those are very, very interesting sectors. And then I think I'll take your question a little bit in a different way for a second and say, what are areas that I'm looking as an investor to put money into aside from, of course, Classiq? I think there's this, I don't know if you call it like this image of, I'm sure everyone has seen it. It says, when everyone digs for gold, invest in the one that created the shovel, right? And so you have Meta, you have AWS, you have Google, everyone that is digging and digging for gold. And in the back, you have NVIDIA that created the shovel. So that's the kind of companies, that are going to be the true winners here. Not just in quantum, by the way.
Okay, so we have to finish really, but if you have last comment?
One comment is, we are in Cyber Week, and I don't know if I'm proud or ashamed that none of us mentioned RSA. Just saying.
Yeah. So the next big thing is food. Bon appetit.